This video a little shorter than the last one. This is section 3.4, composition of functions. And before we get into the actual composition of functions, I just want to remind you about how functions can be added, subtracted, multiplied, and divided. So when you see something that looks like this, f plus g of x is how you would read that. You can actually just take f of x plus g of x. You'll be combining like terms and simplifying. F minus g of x is just f of x minus g of x. Multiplying, same thing here. The only difference now with f divided by g of x, you would take f of x divided by g of x, but now we have created a rational function, so we have this additional restriction that the denominator cannot be 0, so we have to consider that. So let's look at an example. Suppose f of x is 2x plus 1 and g of x is x squared minus 2. Well, what's f plus g of x? Well, we're going to take f of x, which is 2x plus 1, and we're going to add to that g of x, which is x squared minus 2, and then combine like terms. Now, I usually do the parentheses, especially when it's subtraction. It's going to help, but the parentheses didn't matter for us here. So when we combine like terms, we have an x squared. There's nothing to combine with that. A plus 2x, and a positive 1 minus 2, so we get minus 1. And that's your answer. So f minus g of x, you start with f of x, and we're going to subtract g of x, which is why we need to make sure we have the parentheses there, because now we have to distribute the minus sign. So we get 2x plus 1 minus x squared plus 2. And I'm going to put them in order with the descending power. So we get negative x squared plus 2x plus 3 would be our simplified answer. For the next one, f times g of x, we're going to take f of x times g of x. We can FOIL this, put it in a box, multiply it out. So we're going to take our first terms and we get 2x cubed. Then we're going to do the outside. I get minus 4x. The inside, I get plus x squared. And the last, I have minus 2. So I get 2x cubed plus x squared minus 4x minus 2. And there were no like terms to combine, but the conventional way to write this would be with the exponents in descending order. So for this last one, so f of x divided by g of x is what I'll end up with. But now we have to consider that the denominator cannot be 0. So off here to the side, I'm going to have x squared minus 2 equal to 0. So then we get x squared equals 2. So x equals plus or minus the square root of 2. So then I would need to say x not equal to plus or minus the square root of 2, because that's what would make the denominator 0. So I have that additional restriction on the domain because of that. So now let's talk about composing functions or composition of functions. So we can also create new functions by a process of combining functions. So the output of one function becomes the input of another. So this process is called the composition of functions. So for example, suppose that I have f of x equals 2x plus 1, the same function I had before, and g of x equals x squared minus 2. Now I want to find f of g of x is how you would read this. Now notice I have an inside function, which is g of x, and I have an outside function, which is this function f. So to evaluate this function, the input of f is the output from g of x. So think of it this way: if I put a value into g and I get a g of x value out, that would be my output, and then I'd be putting that value in as an input into this function, then to get my final output. So when you're evaluating a composition of functions, and we did these last year in Algebra 2, so notice what I did, and I have it in red. I took my g of x function, which is equal to x squared minus 2, and I just put it into function f. So I replaced g of x with x squared minus 2, And so then now notice what I did, 2x plus 1, but instead of an x, I did 2 times x squared minus 2 plus 1. So I'm just putting one function inside of the other and simplifying that. So going on here, I would have 2x squared minus 4 plus 1, or 2x squared minus 3, and that would be my answer. Now another way to write this looks like fog, but it's not. You read this as f of g of x. So you want to be careful not to look at this and think it's a times sign. This does not mean f times g of x. It's f of g of x. When you have it in this notation, it's the function that's closest to the x. That's the inside function. This is the outside function. I like to write it in this other format because it gives you a visual that g of x is inside f of x. You can really see that, but your textbook will write it both ways, and you need to be familiar with both ways. So back to my same two functions, f of x and g of x. I'm going to switch it around now. So instead of f of g of x, I'm going to find g of f of x. So that means I'm going to take this function and put it inside g of x. So that means where I see an x, I'm going to replace that with 2x plus 1. So for g of f of x, I'm going to have, instead of an x squared, I'm going to have 2x plus 1, quantity squared, and then I'll have a minus 2. So f of x goes inside of g of x. So this I'm going to have to multiply out. Remember, you square the first term, multiply and double, square the last term. You'll do that a lot, and simplify. And that's my answer. Now sometimes you're just asked to evaluate not g of f of x, but g of f of 2. So what that's telling me to do is plug a 2 into function f and get an answer. When you get that answer, plug it into function g and get your final answer. So that's one way. So I could take this 2 and I could plug it into, let's do that. So if I do f of 2 and I plug that in up here, I'm going to get 5. And then I'm going to take that answer and plug it into g. So if I take g of 5, then I'm going to take 5 squared is 25 minus 2 is 23. But I want to show you something. We already evaluated g of f of x. So take the new function we have and actually plug in a 2 into that. 4 times 2 squared plus 4 times 2 minus 1. So here I'm going to get 16 plus 8 minus 1, which is 23. So I get the same answer. I can do it in 2 steps, or since I already created a new function right previously, I could use my new function and plug that into that composite function. So let's evaluate f of g of 3. I actually could go back to my previous slide, or I could just do the 2-step. So I'm going to start by evaluating g of 3, because that's the inside function. So I plug a 3 in here, I get 3 squared minus 2, so we get 7. And then I'm going to plug that into function f. So I get 2 times 7 plus 1, which is 15. You could actually go back to the composite function from the previous, if you backed this up, and you could plug a 3 into that new function and you would see you'll also get 15. Well, sometimes you don't have the actual function. Sometimes you just have a table of values. So this particular table of values, I have 4 different values of x. I have 4 different values, corresponding values of f of x, and some corresponding values of g of x. Think of this, I could write ordered pairs, 1, 3, 2, 8, 3, 2. So I can think of them as ordered pairs. But I don't have the actual functions. So if I'm asked to evaluate g of f of 4, I'm going to start with the inside function, and I'm going to figure out, well, what is f of 4? So I have to find, the 4 is the x. So I look and see, okay, x is 4. And I want to know what is f of 4. So I'm going to look in this column that tells me the f of x values. So I see f of 4 equals 1. So I'm just going to put a 1 right here, because that's what f of 4 equals. So now I have to evaluate g of 1. So then I find out when x is 1, and I look over and I see that g of x, or g of 1, is 5. So that would be my answer for that problem. Now I have to do f of g of 3. So I'm going to start with the inside function, so I have to evaluate g of 3. So I find the 3. Whoops, didn't mean to draw that line, but that's okay. G of 3 is 3, so this becomes a 3. Now I have to evaluate f of 3. So I look on my chart and I see f of 3 is 2, and that would be my answer. Now I made a note down here, not all compositions can be found with this chart. For example, g of f of 2. So if I start with the inside function f of 2, I see f of 2 is 8. But I don't have g of 8. It's outside of my domain. I don't have that value, so that is not possible to actually compose it with that value. So that can happen in some cases. Well, how do you find the domain of a composite function? So let's talk about that. So suppose we have, and I changed up the functions this time, that f of x is 1 over x minus 3, and g of x is the square root of x plus 4. And I want to find the domain of f of g of x. Now, one way you could do that is you could actually find out what f of g of x is, and then you could look at that and talk about the domain from that. But I want to do another approach. So if you think about what this means, f of g of x means that g of x becomes the input for f of x. But think about this, you cannot input a value that's not defined. So I can't input a value that's not defined for g of x. So I have to look up here at g of x, and remember from what we did in the last section, I can't take the square root of a negative, so x plus 4 has to be greater than or equal to 0, which means x is greater than or equal to negative 4. So we know that this has to be true. That's what I wrote here. So I know right off the bat that x has to be greater than or equal to negative 4. Well, I also know that I can't input a value that makes the denominator of f of x 0. So f of x is 1 over x minus 3. I can't not input a value that would be equivalent to a 3. So we can't input a 3, so then we take g of x and we say it can't be equal to 3. So if I see what that value would be, if I square both sides, I get x plus 4 equals 9. So x equal to 5 would make that true. So I have to say that x cannot be equal to 5. I have to exclude that. Well, let's write this in interval notation because you know we kind of have to practice that. So I already know that x has to be less than or greater than negative 4. So here's negative 4. It has to be greater than or equal to. So it's all these values here. But 5 is going to show up somewhere along here, and it's going to have an open circle on it because it can't include that, but everything else. So I have negative 4, comma, 5, parenthesis, union, 5, comma, infinity, because everything else would work. So that's what you would do. So you might have to, pause this or go back and kind of replay. So whatever the inside function is, you have to look at that domain because that kind of drives it. That the domain of your any exclusions that you have are going to be excluded in the composite function as well. But then you also have that additional thing to think about that you have to look at the outside function and make sure in this case that we couldn't have 0 in the denominator. Okay, I love the title of this, Decomposing a Composite Function. That just sounds kind of gnarly. Find functions f of x and g of x so the given function can be expressed as h of x equals f of g of x. And I know that might sound complicated to you, but actually this problem is pretty simple. So what you want to do when you look at this is a composition of two functions. So you want to look for an inside function. So you kind of just, and you see some parentheses and there's something inside the parentheses. Call that g of x. So I'm going to let g of x equal x plus 2. And then replace what you called g of x with an x. Okay, and that's going to be your outside function. So in this case, it's f of x. So I'm going to replace the x plus 2 with an x, and I get 5 over x cubed. And that's all there is to it. Notice that if I put g of x inside of f of x, I would have this. Okay, so again, look for an inside function, call it g of x. Replace what you just called g of x with an x to help you get the outside function. Here's another one. Find an inside function. Well, looks like this 2x plus 3, I mean, it's obvious. It's inside the absolute value. So that's going to be g of x because we were told that g of x is the inside. So g of x is 2x plus 3. And replace what you call g of x with an x. So f of x, the outside function, replace it with an x. Done. Not too hard. Last problem, you'll be happy to hear that. Of course, you might not like it when you see the functions. Given f of x equals 1 over x minus 3 and g of x equals 4 over x plus 3, find the composition of functions, and we're going to go both ways. So we're going to start with f of g of x. Okay, so this one is going to, g of x is going to go inside of the other, so I get 1 over. Instead of an x, I replace it with 4 over x plus 3, and then I have a minus 3. As a matter of fact, I should be consistent. Usually I put parentheses. So I replace the x with 4 over x plus 3. Now the parentheses really aren't doing anything for me, so notice I have a plus 3 and a minus 3. Isn't that nice? So we get 1 over 4 over x, and hopefully you all remember, when you divide by a fraction, it is the same as multiplying by the reciprocal, so this becomes x over 4, and that is your simplified answer. Let's go the other way. G of f of x. So f of x goes inside of g of x. So this is going here. So we get 4 over 1 over x minus 3. And then the plus 3 is out here. Okay, so notice I replace the x with 1 over x minus 3. Okay, well, remember that when you divide by a fraction, it is the same as multiplying by the reciprocal. However, this plus 3 is completely separate. So it's going to become 4 times, and then when I flip this over, it's x minus 3 over 1. And you can put this over 1 if you want. And then plus 3. So then I'm going to distribute this. So we get 4x minus 12 plus 3, because this was just over 1. So we have 4x minus 9. And that's simplified, and that's all there is to it.